All right, everybody, I want to welcome you to Concept Application 17.1c Solutions. This is on the first law of thermodynamics. All right, so you guys, you learn how to find the specific heat of different substances as well as heat energy given off or absorbed. Okay, you watched a video podcast on that. You solved some questions out of the book as well as a couple worksheets. Okay, so let's go ahead and go over these. So I'm going to go over 9, 10, and 72. For those of you that were not assigned the STAR problem, just forward the video and just go over the part where I go over the worksheets, the answers to the worksheet. Okay, so now you guys, for number 9, you were to use these values. 1.0 calories per gram times degrees Celsius when asked to find heat in calories. 4.18 joules over gram times degrees Celsius when asked to find heat in joules. Okay. All right, so let's go over number 9. So number 9 says, using calories, calculate how much heat 32 grams of water absorbs when it is heated from 25.0 degrees Celsius to 80 degrees Celsius. How many joules is this? Okay, now the problems that I go over and explain, you are required to copy them down. All right? Okay, so you're required to copy this one down, number 9. You have to copy everything I write down, everything I have, even if you got it right. Okay, so let's go over this. So the first number given in this problem is 32 grams. Okay, that's the mass. All right, we're given the mass. Then we're given two temperatures. Okay, the initial and the final temperature. All right, now we have to subtract those temperatures, and that gives us delta T. Okay, 80 minus 25 is 55 degrees Celsius. That's delta T. Okay, now we're given the specific heat, capital C, lowercase p. I'll just say CP is 1.0 calories over grams times degrees Celsius. That's the specific heat. Okay, in the problem. All right. Okay, that's the specific heat of water. So we're trying to find how much heat energy. That's how much heat energy is absorbed. So we're going to put a question mark, and then we put Q. How much energy the water absorbs, okay, given this temperature change, specific heat, and the mass of the water. Okay, so we're going to use this formula. We learned from the video Q is equal to mCp times delta T. Little dot here means these guys are all multiplied together. Okay, so now we're going to plug these in. So the mass is 32 grams. Specific heat is this value here, and delta T is 55 degrees Celsius. That's there. So we multiply that together, and we come out to 1760 calories. Okay, so that's the answer in calories. Now it also asks you to find the answer in joules. So you got to change that to joules. So you're going to set up a T-chart. Remember, we learned how to do these not too long ago, so you go from calories to joules. So remember, there's 4.18 joules for every calorie. Okay, that's in the lesson notes. The calories cancel. All right, and you multiply the top numbers, divide by 1, and that's going to give you 7356.8 joules. Okay, so that's the answer to number 9. All right. Okay, the answer to number 10, I'm just going to tell you what it is. Number 10 is going to be 0.236 joules over G times degrees Celsius. Okay, that's number 10. All right. Okay, on to the next one. All right, number 72. For those of you that were assigned the starred problem. Okay, 72 is, go ahead and write that down. (72) is 1420 grams. Okay, that's the answer to number 72. Okay, we're going to go ahead and go over the worksheets. All right, let me go ahead and get those ready. Okay, so the first worksheet was finding the specific heat of substances. Okay, so let's do number 1. Okay, a 15.75 gram piece of iron absorbs 1086.75 joules of heat energy, and its temperature changes from 25 degrees Celsius to 175 degrees Celsius. Calculate the specific capacity of iron. Okay. Okay, so for that one, what we're going to do is this. We're given 15.75 grams first. So you guys, you got to copy this down, everything, okay? So 15.75 grams is equal to the mass. Okay, now we're also given 1086.75 joules. That's equal to our Q value. Okay. And then we're given 2 temperatures. We subtract those. That's equal to 150 degrees Celsius. And that's equal to delta T. Okay. Make sure you copy this down, you guys. Okay, now we're trying to find the specific heat given these values. So we're going to use Q equals M times CP times delta T. So we plug in our values here. Okay, so Q is equal to this number here equals, the mass is 15.75. Specific heat we don't know, so we just put capital C lowercase p. And then delta T, remember, is 150. Okay? Okay, so we multiply these two numbers, and we just put the CP behind it like that. Okay, now, so this is what we come up with. Okay, feel free just to pause the video and then just restart it, okay? Okay, so you have to divide both sides by this number, this side and this side. Well, if you divide by this side, this cancels out. So that turns into CP equals this number divided by that number. Okay? And then you have as your answer 0.46. All right, so make sure you have all that copied there. Okay, I'm going to go on to the next problem. If you're not done, pause the video and then restart it. All right, so that's the answer to number 1. Let's go over the next one. Okay, so number 2. Number 2 says, how many joules of heat are needed to raise the temperature of 10 grams of aluminum from 22 degrees Celsius to 55 degrees Celsius if the specific heat of aluminum is 0.90 joules over grams times degrees Celsius? Okay, so right in this area you must copy the following. Okay, so for that one, we're given 10 grams is the mass. Okay, we're given 2 temperature values, 55 and 22 degrees. We subtract those. That's 33 degrees Celsius. That's our change in temperature. Our specific heat is 0.90 joules over grams times degrees Celsius. Okay, we're trying to solve for Q. All right? The amount of joules needed to raise the temperature. Okay, so what we're going to do is we set Q equal to M times CP times delta T. The little dot means times, okay? We plug in our values like that. Remember, mass is 10 grams, specific heat is 0.90, and delta T is 33, okay? And that comes out to 297 joules, all right? Okay, so most of the problems on this worksheet are just like number 1 and number 2. However, there's one more I'm going to go over. So pause the video right now and then restart it when you're done. I'm going to go over number 8, okay? So number 8 was a little challenging, so I'm going to go over that. Okay, now number 8 says, so you guys got to copy everything down, number 8. A 0.3 gram piece of copper is heated and fashioned into a bracelet. The amount of energy transferred by heat to the copper is 66,300 joules. If the specific heat of copper is 390 joules over grams times degrees Celsius, what is the change of the copper's temperature? So we're trying to find the change in temperature here, okay? Okay, so right in this area here, make sure you copy this down. So we're given, our first value given is 0.3 grams is our mass. We're given the Q value, the joules, okay? This is the amount of heat given off in the problem, 66,300 joules. And then we're given the specific heat value, which is 390 joules over grams times degrees Celsius. That's our specific heat. Okay, and then we're trying to find the change in temperature. Okay, so you're going to still use this formula here. Okay, now you guys, there's a couple ways to do this. You can go ahead and get delta T by itself and plug in the values, or you could just go ahead and plug in the values here. So I went ahead and did this. So Q is equal to this number here, M is equal to that number, Cp is equal to that number, delta T we don't know, so we multiply these two together. So we end up with this number equals this value times change in temperature. Okay, pause the video right now if you're not done copying this, then restart it. Okay, so we divide both sides by this value here. Okay, this side cancels, so it's 66,300 divided by 117 is equal to change in temperature, and that's equal to this number here, okay? 566.66 degrees Celsius, and that is our change in temperature, all right? Feel free to pause the video and finish copying this, and then restart the video to go over the other, for the rest of the problems, for the rest of the answers. Okay, so I'm going to go ahead and put up the answers to the rest of the problems. Most of them are solved just like the ones I went over. Okay. Okay. So for the first worksheet, that's this one right here. Find the specific heat of substances. The first four are these answers here. Okay. Number 1, let me go ahead and zoom out. You have number 1, 0.46. Second one, 297. And then you have 1.8. Put this up here, and then you have number 4, 13,794 joules. Okay. Okay, let's go over the other ones. Number 5. Okay, so that's 5, 6, 7, 8 on this page. Here are the answers. So number 5 is 0.14. Okay, number 6, 0.0573 joules over grams times degrees Celsius. Okay, number 7, you have 41.866. And number 8, 566.67 degrees Celsius. Okay? Okay, now, for those of you that were assigned the last page, I'm going to put up the answers for that. The rest of you write down how many you missed and then let me know, get your correction stamp, okay? Okay, so here are the answers to the last worksheet. All right, so go ahead and you can press pause. Let me go ahead and zoom in here. Okay, go ahead and press pause. Go ahead and correct your answers here. Let me put up the last one. Okay, and then when you're done, write down how many you missed next to your name, and then let me know. Make sure you line out the ones that you missed, write in the correct answer next to it, write how many you missed total next to your name, and let me know to get your correction stamp. All right, so that's it for this video podcast.